Okay, we're continuing on with lesson 3.2, example 2. And again, find the upper bound supremum and the lower bound infimum for set S as a subset of all real numbers. State if supremum and infimum are in set S. Okay, so we have a problem such as S set S equals to all elements in X such that the absolute value of 2x plus 1 is less than or equal to 5. Okay, so we're starting with, since this is the absolute value of 2x plus 1, that'll be less than 5, less than or equal to 5, but it'll also be, because it's absolute value, we have to look at greater than or equal to a negative 5, because we don't know if this produces positive 5 or negative 5 because it's an absolute value, so we have to put positive and negative 5 in there. Okay, so again, now we solve for x, and so we apply minus 1, minus 1, minus 1 to all three, and we get a negative 6 is less than or equal to 2x, and that's less than or equal to 4. And then we divide by 2, divide by 2, divide by 2 into all three, and we get a negative 3 that's less than or equal to x, and that's less than or equal to 2. Okay, so if we're looking at this on a number line, right, and so this would be 2, so that's our least upper bound, and we have negative 3, that's our greatest lower bound, and because it's less than or equal to and greater than or equal to, they're closed because they include it. So here's all elements in set S. Okay, so we have here our upper bound, B1, B2, and so on, and A1 and A2 and so on, going the other way. So everything else is all real numbers. So S is a subset of all real numbers. All right. Okay, so from here, we're going to say a set S has an upper bound, that's our B part, the B's, B, if there exists for all X element in set S, there exists a B where X is greater than or equal to B. Thus, we can say the upper bound, is the element in set B such that B is greater than or equal to 2. The supremum of set S is 2. Okay, is the supremum an element of set S? Is supremum in set S an element of set S, and we can say yes, because x is less than or equal to 2, so therefore our least upper bound is an element in set S. Okay, and therefore, so, and then we can also say that we define the A where there's for all x elements in set S, there exists an A where x is greater than or equal to A. Therefore, the upper bound is A, and then such that A is less than or equal to a -3. The infimum for in set S is an element, is the infimum an element in set S? And we can say yes, it is, because x is greater than or equal to -3, so it is. And so the infimum for set S is -3. Okay, and that concludes example 2.